Hi, everybody. Welcome to Spatial Data Science, a tour. I'm Lauren Bennett, and I will be joined throughout this workshop by my colleagues Alberto Nieto, Sean Walbridge, and Atma Mani. We all work very closely on the various parts of the ArcGIS platform that support spatial data science across the platform, and we're very excited to talk to you about that today. Um, we wish that we were seeing you in person, but of course, current events made that impossible. But we are really glad that we get the chance to share this with you virtually. So let's get started. Now, I think before we jump into what the what spatial data science looks like across the platform, it's really important to kind of have a sense of what spatial data science is, kind of more broadly. So we really think about spatial data science as these seven kind of sub capabilities, these seven ways that we um, explore, understand, analyze our data. So it starts with data engineering. This is really where we dig into our data, we clean it up and prepare it for analysis. We geo-enrich it and use geography as this key that connects disparate data sets. We add variables and transform variables to make them appropriate for modeling. Lots of work goes into this data engineering step. I'm sure that anyone who's done any sort of analysis or data science knows that, as unfortunate as it is, we probably spend the majority of our time in this data engineering phase. It is really, maybe it's not the most fun part of the process, but it's definitely one of the most important. And geography and GIS and thinking spatially has a large role to play in that. So next we have visualization and exploration. This is really where we start to understand our data, understand the patterns that exist in our data, understand what our data is really capable of and what problems that we can answer or solve using our data. It's where we also, it's not just at the beginning of an analysis process that visualization and exploration comes in. Some of the most important places we visualize our data is actually throughout the analysis process. We run an analysis, we visualize the results, we explore those results in a way that helps us understand if that analysis was effective and if it was valid and if we need to continue to iterate on that part of the analysis process. So visualization and exploration is at the beginning when we're understanding our data, it's in the middle while we're analyzing our data, and then it comes up again big time when we're trying to share and collaborate and tell the story of that data. So then there's spatial analysis. This is kind of like that bread and butter. This is where we really start to ask questions. This is the pattern analysis, space-time analysis, terrain analysis, predictive modeling, all of those things where we ask questions and we answer them using spatial and non-spatial data and spatial and non-spatial algorithms, and really start to solve the problems that we're facing. Now, really within this topic of spatial analysis falls both machine learning and AI and big data analytics. We call them out specifically here and kind of give them their own category because of how much current research and development and focus is being spent in these particular areas of spatial analysis. So machine learning and AI are a huge part of this. There's so much work being done on bringing these algorithms and this new way of kind of thinking about how we analyze our data into ArcGIS, and we'll talk a bit more about that later. And within this, there's also a lot of work going on in terms of how we parallelize and distribute our analytic processes so that we can work on larger and larger volumes of data, whether we're talking about massive feature data sets, points, lines, and polygons, or massive collections of rasters or imagery, which is increasingly, with the rate at which we're collecting this kind of data, becoming more and more necessary for us to be able to analyze that data at scale. Underlying a lot of this is the ability to model and script, the ability to take all of these various pieces of the puzzle and string them together in ways that allow for us to reproduce our results, to automate our results, to operationalize those analytical processes so that they're run, daily or weekly or within our organization, so that they are exposed to as many people as possible. And being able to do that modeling and do that scripting underlying our analytical workflows is critical, and we'll talk quite a bit about that too. And then finally, there's sharing and collaboration. This is actually a really key part of spatial data science. It may seem somewhat unrelated, like, of course, we can share and collaborate and provide reports of our analysis, but actually this is an integral piece of the process, because it doesn't matter how great our analysis is if nobody's using it. Then what's the point, right? If nobody can understand it, if there's no good way to share it, if we're not telling the stories well, then it's all kind of for naught. So these are the pieces of the spatial data science puzzle. And within ArcGIS, these are really an underlying capability of the entire platform. It's really important to think about the idea that spatial data science isn't just something that happens, let's say, in our spatial data science workstation, which is ArcGIS Pro. It's also that same foundation, that same framework that makes up the analytical capabilities that are inside of Pro, let's say, is that same framework that also powers enterprise. And it's that same framework that powers the things that we're doing in the cloud. So this framework, this spatial data science capability, which underpins the entire ArcGIS platform, really is foundational to being able to take something from a workstation, push it into enterprise, operationalize it, or start an enterprise and do your work in that scaled environment where everything that you're doing is already kind of pushed out organizationally. There's so many different ways that we can take advantage of these spatial data science capabilities, and it really just depends on the way that you need to solve your problem. And depending on that, you'll pick which way you want to experience this capability. Now, a huge part of the spatial data science capability within ArcGIS, especially for our Dev Summit attendees, is really Python. Python is this glue that holds together all of these different pieces, and we have made huge investments in Python over the last few years and continue to. And with that, I'm going to pass it over to my colleague Sean Walbridge, who's going to talk a lot more about the role that Python plays across the platform and specifically in spatial data science. So Sean, take it away.
The ArcGIS platform supports many languages, but there's really only one language that stands apart in its deep integration to the platform and its role in spatial data science, and that's Python. And Python is available in every major desktop and enterprise environment, as you can see in this diagram, and we're adding it in new places all the time wherever it makes sense. And this extends beyond just a superficial integration. For many of our product offerings, the Python distribution we provide is rich, providing you access to hundreds of Python packages and components you can use for your own spatial data science workflows. But it isn't just about utilizing that great work of those open source libraries. The two real drivers here are the ArcGIS Python libraries. ArcPy is a comprehensive and powerful library for all your spatial analysis needs. The ArcGIS API for Python also provides you with rich mechanisms for interacting with your WebGIS. It's usable in any context that you have Python available to you, and it includes a rich submodule, ArcGIS Learn, focused on bringing spatial data science methods directly to developers. As changes arise in the Python community, we also carefully evaluate them for inclusion into our platform. Something like notebooks might initially start out in one or two areas, but the vision we're working toward is a consistent and holistic experience for workflows, so that the work you do today in, say, notebooks in Pro can be deployed into your enterprise environments, or the notebooks that you're authoring in ArcGIS Online or Enterprise can feed workflows in the desktop and runtime environments.
Thank you, Sean. That was such a great kind of overview of Python across the platform, and how it plays into our workflows with spatial data science. Now we know now that notebooks play a really big role in the evolution of how Python is being used, really across the world in all sorts of different ways. Um, and we want to give you a little taste of how notebooks kind of manifest themselves all across ArcGIS. So to start that off, we're going to do a demo of Notebooks in Pro, which is brand new. We're really excited about. We think it's going to, we're really excited to see what you guys do with Notebooks in Pro. So for that, I'm going to pass it over to Alberto.
Thank you, Lauren. Hi, everyone. I'm excited to show you Jupyter Notebooks within ArcGIS Pro. If you're not familiar with Jupyter Notebooks, they're quite a useful tool if you write Python code. And to get started, you can simply right-click a folder connection from your catalog pane, and you'll see this new option to select a notebook. Let's go ahead and name our first notebook and open it. You'll notice that everything happens within ArcGIS Pro. Jupyter Notebooks are quite useful because they let you write code into cells, which are independent from each other. So this is one such cell. I can enter some code to simply import ArcPy. And that can be quite useful if you're trying to prototype a workflow. If you're not certain of which steps you will take in your workflow and you want to test a few different options, having code into discrete cells can be quite important. Additionally, cells are not just used to write code, but they can also be used for markdown or narrative to help explain what's happening in your code. So for instance, I can enter some descriptive information here and put my markdown cell above the pertinent code cell and help others learn from the code that I've written. So for this example, I want to show you a more complete notebook. And in this case, we're going to take a look at some data for a pertinent issue, the coronavirus. In this case, we may be aware of a lot of the applications that are being built to display case data throughout the world. But very often this case data could be supplemented with the data that shows how many tests are occurring for each state in the United States or perhaps for each country throughout the world, since testing is quite important. So we found a web page for the COVID tracking project, and this web page collects information from several states and provides that data to us as an API. So if we select this, we can actually navigate this web page and see what that data would look like. It's a JSON. And the purpose of this notebook is simply to help someone in ArcGIS Pro quickly ingest this data and be able to work with it as a feature class. What I like to do with notebooks is be pretty verbose with describing what's going to happen. So the general process is quite simple. We're going to ingest some data. We're going to prepare it by geo-enabling it and calculating some testing rates. And also we're going to export it to a local feature class. Another useful feature of notebooks, if you're getting used to them, is the ability to dock cells so that you can quickly organize the sequence and not overwhelm a person up front. Within the ingest data part, we have a few cells that really just connect to that API that I briefly showed you. And a useful part of notebooks is also the ability to use pandas data frames in Python and visualize them directly within the notebook, which helps them stand out from other development environments that maybe resort to seeing that at the end of the execution of the script. So over here, we see actually the data set pertaining to each state's amount of tests. Additionally, we have other metrics that may be of interest, and also importantly, the last update date for that particular state. We're going to use that, and we're going to prepare it by essentially joining the test data with different states to bring some geometry and actually use it as a feature class. In this case, we can incorporate the ArcGIS API for Python, bringing in a living atlas layer of states. And what we're doing here is simply querying a few fields of that data set pertaining to the state, the subregion, the population, and the geometry. And we can go ahead and merge it using pandas by doing pd.merge, bringing in our states data frame and the testing data set that we brought earlier. So now we have that data frame that includes the geometry as well as the test data that we need. We can also go ahead and calculate the test rate. So if I insert a cell here and expose the first few records of the data set, we can see that there's now a new field that has how many tests are occurring per 1 million residents. This is a very important metric these days, particularly to determine if we're tracking this disease properly. Finally, what we want to do is export it to a local feature class. And in this case, we have some code that enables us to do that. So I'm going to go ahead and dock my notebook here. And once we execute this, we'll essentially see that a feature class is going to be created here in our table of contents. So the notebook interacts with our current active map. And what we can see, we'll remove the archive layer that we produced here for historical data. But what we can see is that we now have a data set that we can work with here. Each state has the pertinent information that we retrieve from that API, including the total amount of tests conducted at that location, the population, and also the tests per 1 million residents. What I like about having notebooks in ArcGIS Pro is the ability to actually do more than just use notebooks. So if I want to quickly configure the symbology of this data set using that test per 1 million category, I don't have to do that necessarily through Python, since that may not be the proper way to really navigate all the options that are available to me. I may want to quickly configure the properties of the symbology simply through this interface that is purpose-built for that type of workflow. And additionally, there's a lot of other capabilities in ArcGIS Pro that really help us explore this data set. So if I want to create a bar chart of the different states and the testing rates across the board, we can simply select the state as our split by here and select our category being the, pardon me, I want to use the numeric field as the test per 1 million residents, not the split by, but the category to be our state. And now we can select a stack ranking so that we can actually set this up as not just a notebook to process that data, but also some exploratory information about how different states are doing pertaining to testing for the coronavirus at the moment. So this is a quick view of how notebooks within ArcGIS Pro can start to fit into your workflow, particularly with data engineering and several steps where Python can be quite useful. Back to you, Lauren.
Thanks so much, Alberto. Okay, so next up, we want to show you kind of a different way to think about notebooks and a different way that we've implemented notebooks within ArcGIS, and that's our hosted ArcGIS notebooks. This is notebooks both in Enterprise and also in ArcGIS Online, and we're really excited about the way that notebooks are opening up spatial data science to all of you, and we're really excited to see the things that you guys do with them. So with that, I'm going to pass it over to Atma. Atma, take it away.
Hello everyone, this is Atma Mani, and I want to give you a brief walkthrough of ArcGIS notebooks. In front of me, I have an ArcGIS Enterprise with the ArcGIS Notebook server installed. When I log in either as an administrator or an account that has notebook privileges, I see a notebook button add or get created in my ribbon at the top. When I click on this notebook button, a new notebook application starts in my browser. Now, this is a regular Jupyter notebook that you're all familiar with, but instead of a blank notebook, you will notice that there is a little amount of starter code that you added. I can do things that are just like in a regular notebook. Like for instance, I can click the run button and log into my portal, run Python cells. I can type Python expressions or math expressions and use familiar keyboard shortcuts like Shift Enter to run it. If I want to insert a new cell, I can hit button A. If I want to remove the existing cells, I can click on X. In addition to regular Jupyter Notebook facilities, we also added a few productivity improvements. So let's take a look at what those are. Let's start with the sign-in operation. If you notice, I would have normally had to type in my URL, username, and password, but all I had to type here is the word home, and that I did not even type it. My notebook just came with a starter code. We call this kind of logging in as the home mode, and what happens behind the scenes is my notebook application uses the account with which I signed into my ArcGIS Enterprise and uses that to log me into my portal in the Python API. And that's what is happening here. This is a friendly warning saying that I have logged in as an administrator and I need to exercise caution because administrator accounts are very powerful. In addition to regular notebook interface, I mentioned about a few productivity improvements. So let's start taking a look at those. There is this add button. When I click on it, a content pane opens up on my left, and I can very quickly browse through and search through all the content that I have in my account. In addition to my account, I can look at other places like things I have marked favorites, groups shared with me, my organization. I can even search across living atlas layers, and I can also search across the wide open ArcGIS online, and very easily I can add content into my notebook and start working. For instance, let me go back to my content, and I want to add this particular layer that I'm interested in. So what happens when I hit on the plus sign? A new cell gets injected, and it has Python code that is displayed here. I can run this, and I can get a preview of the world earthquakes item that I'm interested in working with. Now I want to start exploring this layer. So for that, what I'm going to do is I'm going to import the pandas library. Then let me write a little bit of Python code to read this into a spatially enabled data frame. So item, as I know it has one layer, run a query on it, get it as a spatially enabled data frame, and let us store this as a data frame object. Now let's go ahead and preview this. I am interested in following PEP 8 coding standards, so let's make sure there's enough amount of space between the equal sign. Now I'm reading this layer into a data frame and displaying that right within my notebook. I'm interested to see how many records and columns are there, so I can just call the shape command, and I know there are 77,000 records in this data frame. Next, what I want to do is I want to make some quick maps and quick exploratory analysis on this. If you notice, there is a date time column, there's a longitude, latitude, and then there is a magnitude column that contains the magnitude of these earthquakes in a Richter scale. If you notice, this data set only contains earthquakes that are over 5 in magnitude. So with that in mind, I want to make a bar chart of the distribution of magnitude. So it's very simple. Let's call the magnitude column. Let's make a histogram. Sorry, bins. And let's make 30 bins, which is pretty standard. When I plot it, you can see that there is a lot of earthquakes between 5 and 6 in magnitude, and then it tapers off. Now, what I am also next interested is that there is a date time column. So I want to analyze across the years. I want to actually aggregate across the years and find out how many earthquakes have occurred in each year. The data set is itself not in this fashion. Every now and then when earthquake happens, and as it gets recorded, an entry happens in this database. Now we need to run some aggregation. Fortunately, it's very simple and easy to do with pandas. But before we do an aggregation by date, we need to let pandas know that actually there is date column. The data type of that particular column is date and it is not string. So let's do that. Let's actually create a new column and call it date. And let's use the pandas date time cast operation and specify which column has to be operated. Let's run this. Oops, my bad. That's good. Now I want to run a group by operation. So let's go ahead and do that. And the by column would be date, accessed as a date time operation. Let's run a count on it. Then let's now plot this. Let's actually capture the output of this into a variable. Then let's make a plot out of that. Aha, almost made a typo there. Let's make the bar as a horizontal bar chart. And because it's going to be a long chart, let's also adjust the figure size. Let's try this out and take a look. This is going to, it's looking a little bit condensed, so let's make it a little longer. I just made a bar chart. What I did here, let me start from here, is that I told pandas, hey, the data type of this particular column is a datetime object, so treat it as such. And instead of changing the value of this particular column, I made a new column which reads the data from this particular existing column into a datetime object and creates this new column. Once this is the datetime object, then I can use a datetime operation, like I can parse it by the year of that particular datetime of that record, and I can start counting how many occurrences of each year happens. And that's what I'm making, and the result of that is stored into this variable. Then I can just simply call plot and make it either a horizontal or a bar plot. This plot looked nice when I made it as a horizontal plot, so that's what I'm giving it here. I'm changing the figure size so it's easier to look at. So what this chart shows us is across various different years, the number of earthquakes over magnitude 5 across the world that has happened. If you notice, we see a particular trend here, and then after the years or before the years 1962 and so on, the number of earthquakes is much lesser. This could be a consequence of recording technology and the kind of systems they use to collect and record the data. Nonetheless, it was pretty easy and straightforward to just query this data set and make an exploratory plot like this and look at the distribution of data values. We noticed that earthquakes is a very geographical phenomena, and we have latitude and longitude, and we also have a shape column on this data set. So we can easily put this on a map and start looking and analyzing that. So let's do that. Now we have an interactive map within our notebook, and we can add our earthquake data set into this. Let's give it a second. There are over 77,000 records to be displayed. There we go. We see that the earthquakes is a massive cloud of points. Now, let's see how we can make use of spatial analysis tools to understand the different patterns that exist. We do not know at this point if there is any kind of a pattern, so we'll have to run a tool to even analyze that. So that takes us into the second productivity enhancement that we have added, which is this analysis button. So once you click on that, you have an analysis pane that opens. This pane is very familiar or similar to the analysis pane that you would have in the map viewer. You'd have a set of standard spatial analysis tools. If you have data that is attached to a big data store, you can run them. You can use a geoanalytics server to run on it and get the results back. If you have raster or imagery data, you have a bunch of tools to run on those kinds of data sets as well. For now, we are going to look at the standard tool, and we are going to take a look at the analyze pattern tool set, and then call this particular tool called find hotspot analysis. I can click on the I button or info button, and I can get a contextual help for what this tool does. Then if I click on the plus button, a Python code snippet is added. Now, if I want to know what the signature of this function or tool is, I can just replace the parenthesis with a question mark, run that cell, and I have a help that gets populated at the bottom of my Jupyter notebook. Now I'm familiar with this tool, so I'm going to dismiss this, and I'm going to call it. The first input it takes is an analysis layer. So that's going to be our item, which contains the earthquakes. And I'm going to leave everything else as default, but I'm just going to give it an output name. Let's give it a name as earthquake hotspots, and let's actually expand this out. Let us fold this down into a so that we don't have a horizontal scroll bar. And this is going to return back an item that contains the result. So let's store it into a hotspot item. Let's go ahead and run this. Okay, my tool has just finished running, and let's now take a look at the result of the hotspot analysis. So this is an item. So let's go and add this back to the map widget. So map1.add layer in the hotspot result. Let's give it a moment. Yes. And you can see that across the world, this tool has analyzed potential hotspots or locations that have statistically significant high values and statistically significant low values. Low values are categorized or symbolized in blue color, and high values show up in. So far, I have shown you data sets that are on my portal, but another feature of the hosted notebook or ArcGIS notebooks is access to local data sets. These are data sets that are mounted on a network directory and that is shared or mounted with your ArcGIS notebook server. So there is this default home folder called ArcGIS, and I have a home folder into which all my local content can be uploaded. I can just hit on the browse button, search for a location within my hard drive. I can click on a particular zip file, like for instance, this was a zip file, and I uploaded it into my account. I created a folder called earthquake, and I added it into this geodatabase file. Now, watch this. In addition to the Python API, I can import ArcPy, and I can easily walk through using this code snippet. I can just walk through the contents of my geodatabase, which is a feature class here called equates, and I can use ArcPy and the rest of all the tool sets and geoprocessing tools available within ArcPy and perform my analysis right within my notebook. In addition to files that are local to me or files that are private to me, which is in my files directory, I can have shared directories that is common and shared with all the other users within my organization. For instance, the samples data folder is something like that, and it is also additionally made as read-only. Now, once I am done with this notebook, I can hit on the save button. I can go ahead, give it a title, populate with some notebooks. A default notebooks being notebook and Python is auto-populated for you. And I can add some more description. I can hit the save, and this notebook gets saved as an item within my organization. Once it is an item, I can look at the info pane and take a look at what the title, the description is. I left it as empty. Now I can edit it, giving it a simple description. I can edit my tags as well. Notice this. In addition, there is something called a runtime, and that says that as ArcGIS Notebook Python 3 Advanced 3.0. This is the third iteration of the advanced runtime, and this is called an advanced runtime because it has access to the Python API and ArcPy. There is a standard notebook runtime that only has ArcGIS API for Python and a host of other data science libraries. The advanced runtime contains everything that the standard contains. In addition, it contains ArcPy and the needed libraries to make ArcPy work. Once I have it as an item, I can easily share it with the rest of my organization. This is a familiar share wizard, and you can share it either with everyone, or in this case, I'm going to share it with all the users of my organization. Once this becomes a notebook within my organization, you can click on the overview and take a look at the notebook. And anyone else that is interested in looking at this notebook can get a quick preview of the notebook by clicking on the preview pane. Here you see a HTML version of the notebook is generated and shown here. The last run state of the notebook is saved as a HTML file, and that is used to populate this preview pane. You can very easily and quickly take a look at the kind of analysis you performed and see where you stopped off, where the first author ended. Now, if someone else wants to run it, they can just click on Open Notebook. This opens within their account. And when they try to run this notebook, when they use the same login command using the home, the original author's account is not used, but whoever is running it at that moment, their account is used to sign into this portal. So when you are sharing notebooks across an ArcGIS Online organization, for instance, when someone runs the notebook, it is their account and their credits that is consumed and not the original author's credits, just for an example. Then at the same time, when someone hits save on a notebook that is shared to them, a new item is actually created. The original notebook is not edited. These are some caveats to keep in mind. Well, working with these notebooks may look like a completely new paradigm or phenomena or pattern of working or performing analysis. And to make this easier and also to illustrate you everything that is possible using notebooks, we added something called the samples gallery. So this gets, if you click on this button when you're within the notebook interface, it takes you to a group within your ArcGIS Enterprise or ArcGIS Online Org. And there are a number of different notebook samples. You have notebooks for GIS administration, things something like, for instance, manage inactive users, setting up license expiration notifications, validating all your federated servers, and things like that. There are another set of notebooks for content management, such as looking at all the web maps and URLs, web maps and web scenes, and any other application within your org, and ensuring that none of them have broken URLs. If they have a broken URL, you can set it up such a way that it runs and notifies you. In addition to administration and content management, we have a lot of different notebooks to showcase spatial analysis and data science. Let me just take a look at it in a card view. You have a variety of different notebooks here. For instance, let's take a look at network analysis. This takes you to a notebook that is from the samples gallery. Click on the preview, take a really quick preview about this sample notebook. And it showcases all the variety of different things that you can do with ArcGIS API for Python, ArcPy, and spatial analysis tools available in the ArcGIS Enterprise.
Thanks so much, Atma and Alberto. Those were really great examples of the way that notebooks are really going to empower the spatial data scientists within the ArcGIS community to do some really exciting things. So the next thing that I want to talk just a little bit about is this idea of analytic engines and the idea that we talked about a little bit in the beginning, that these components of spatial data science, this capability is really available across the platform. And the way that we think about this is that there are these powerful analytic engines that are this foundation. And there are a couple of different analytic engines that power spatial analysis and data science throughout ArcGIS. So, of course, as ArcGIS users, you're very familiar with the geoprocessing framework. It's almost 1,600 tools and even more functions and capabilities within ArcPy that are this geoprocessing framework. This is all of those tools that allow you to string together really complex workflows to solve all sorts of problems. So that's definitely one of those foundational technologies. Now, in addition to that, we've also got a series of tools that are available through Enterprise and in the cloud. So that's standard analysis tools. Those are some of the key tools that work on features, so points, lines, and polygons within ArcGIS Online and in Enterprise for you to be able to do some of the most common spatial analysis functions, things like hotspot analysis, summarizing within and nearby, geo enrichment, lots of different functions that fall into that standard analysis tool set. There's also the geoanalytics tool set. This is a set of tools that are built using Spark, and it's all about that distributed processing and being able to analyze massive collections of data and to do it distributed across using Enterprise, and we're actively working on bringing that to ArcGIS Online as well. There's also raster analytics. Raster analytics is really about doing processing raster and imagery data, and really powerful tools that allow you to both do kind of raster function based analysis where you can analyze things at resolution, so it works really quickly and scales really well even for massive data, and then also the back end tools that allow you to do it not at screen resolution, but to save those results out and operationalize those results in the ways that you need to. And that is really built to scale with massive imagery collections, because we know that raster and imagery data, especially at the scale at which it's collected now, is massive. So we need to be able to scale that analysis, and that's what raster analytics is really all about. And then finally, I would include in here these bundled and integrated open source data science libraries. These are, there are so many that the ecosystem of open source data science libraries is huge, whether it's R or Python. There's just so much out there, whether it's scikit-learn or TensorFlow or PyTorch or even just SciPy and NumPy. There's so many different packages out there that are helpful in data science workflows, pandas. So we're constantly working on bundling those and integrating them the best ways that we can, so that you can take advantage of them within ArcGIS. And we spend a lot of time focused on how we can make it as easy as possible for you to do that integration. And we'll talk about that a little bit more in a few minutes. So when we think about spatial analysis and data science, I know that one of the things that definitely comes to mind when you hear data science in general is probably something along the lines of a bit of a word soup. There's lots of buzzwords in this area. Certainly the ones that stand out and that are really meaningful, definitely artificial intelligence, machine learning, and deep learning, and they're really subsets of each other. So we've got this bigger kind of bucket, which is artificial intelligence. Within there, we've got machine learning, and then a subset of machine learning is known as deep learning, really a focus on neural networks. And certainly within machine learning and deep learning, this is where we're spending large portions of our time thinking about how we can do a number of things, both bringing in machine learning and deep learning directly into ArcGIS, and then also making sure we ease the path for integration with outside packages. And we really are focused on both of those things quite a bit. So I just want to spend a little bit of time talking about what machine learning is, because I think in the context of spatial analysis and data science, we've talked about the fact that it's available everywhere. We've talked about some of the ways that you can access it through notebooks using Python. But what are you really doing? And one of the things that people are doing a lot of right now is machine learning. So what is it, right? It's a set of data-driven algorithms and techniques, and some of the most common things that people are doing, especially in this area of spatial data science, fall into these categories of prediction, classification, and clustering, or in some cases, regression, classification, and clustering. Now, I do think it's important to kind of acknowledge that there's kind of two types of machine learning in the context of spatial data science. So we've got some of those more traditional machine learning methods that are out there. They are not inherently spatial methods, but the research has shown for many of them that they can be very useful for even for spatial problems. Um, the random forest algorithm is a great example where it's not inherently a spatial method, but it has been shown to be really, really good at solving even spatial problems. And so there's quite a few of those traditional machine learning techniques that have proven to be really great at solving spatial problems. There's also these inherently spatial machine learning problems or algorithms. And this is where we really incorporate geography into mathematics, whether it's some measure of shape or density. Oftentimes it's more about spatial connectedness or proximity, what it means to be neighbors, and incorporating that concept into the algorithm. The idea that I'm more related to features that are closer to me, very much in line with Tobler's law, the first law of geography, that things that are closer together are more related than things that are farther apart, and finding ways to incorporate that into algorithms. And so there's a number of those, and we certainly focus on those in our R&D efforts and bringing those into the software as well. It's also definitely true that these machine learning techniques and even deep learning techniques, neural networks, they're not new necessarily. Certainly there's a lot of new research happening and new things are popping up all the time, but fundamentally machine learning and deep learning have been around for actually several decades. What's different now, and the reason we're really seeing a revival of some of these methods, is because they are very computationally intensive and they require a lot of data to be useful. So a lot of them really only become good at what they're doing when they have massive amounts of data, and the computations on those massive amounts of data are pretty intensive. And so because of all of the advancements that have been going on in terms of storage and parallel and distributed computing, we're really seeing this resurgence of machine learning and deep learning because finally these problems are actually solvable. And we are certainly at Esri very actively working on continuing to advance parallel distributed computing so that we can continue to bring machine learning and deep learning into GIS. So ArcGIS actually has tons of machine learning tools. Some of them have actually been there for quite a few years. We've got tools that fall into these categories of classification, prediction, and clustering. We've got lots of tools for, you can think of kind of traditional image classification that we've been able to do for a long time. We've got quite a few tools that fall into this prediction category, whether it's predicting the category that something will fall into, predicting the value that something should have, or forecasting. Lots of different, also things like kriging would actually fall into this prediction category. And we've got quite a few methods that really are very data driven and fall into this machine learning category within prediction. And then finally, clustering. Clustering is definitely a very common spatial application of machine learning, where we're looking for spatial clusters in our data. It's not always about looking for spatial clusters in our data. Sometimes it's clustering in attribute space, or maybe it's clustering in both spatial and attribute space. And so there's a lot of different ways that clustering kind of comes up within ArcGIS, both using machine learning tools and then also lots of clustering techniques that are in the more traditional statistical space, but that are equally important, especially when it comes to solving these problems. I mean, we're talking about machine learning here, but I do think it's worth mentioning that it is very dangerous to come into trying to solve a problem with a focus on applying a particular method. You know, unless you're working on, let's say, a school project and you've been told to use a particular method, most of the time we have a question that we want to ask or a problem that we want to solve, and that's really the best place to start. We should be focusing on the problem. And if it turns out that a machine learning method is the best way to solve that problem, great. But if it's not, we should be really open to using the best tool that solves our problem. And often the best tool that solves our problem is the simplest tool that solves our problem. just because we can complicate things doesn't mean that it adds value. And so thinking through that, I think, is also really important. All right, so with that, we definitely don't have time to demo all of this. We don't even have time to demo a tiny fraction of it, but we want to give you a little bit of a taste of what's possible and some examples of how these kind of manifest themselves within ArcGIS. So I'm going to pass it over to Alberto, who's going to start by talking about clustering and then move a little bit into the deep learning space. So I'll pass it over to you, Alberto.
Thank you, Lauren. So within the context of clustering, my first demonstration that I wanted to share is by some of the work that our users do at the World Food Program. They're in charge of ensuring that vulnerable populations are well fed, regardless of their circumstances. And a key part of that workflow is what they call integrated context analysis. Integrated context analysis really has to do with comparing different indices for different regions of the world. This deals with looking at different variables that may describe a region. In this case, for example, we have Mali and 4 different maps that show different ways to measure vulnerability with respect to feeding. In the top left, you see a population index map that simply shows us where population is greater. You also have socioeconomic indices in the top right. In the bottom left, you have ethnopolitical exclusion. So how included are different ethnicities in the political process in Mali? And areas in dark mean they're more excluded, particularly because of their ethnicity. And finally, you have conflict at the bottom right, where darker means more conflict. So very often the World Food Program is in charge of comparing these different indices and designing programs to remediate situations where people may not be fed properly. And part of that may be to average these 4 indices into an overall vulnerability index. But there's difficulties with doing that because you lose some of the information that each of these individual 4 metrics provide. And that can be important when they're designing the teams that go and actually distribute food or help supply chains to make sure that people are fed. So another approach to do that is actually using some of our geoprocessing tools. For example, this one is called multivariate clustering, and it allows us to take all of these different criteria and find clusters of attribute values in the data. I'm simply going to close these 4 maps. Go back to a single map and select our country, and then select the analysis fields that we want to cluster by, starting with population index, including socioeconomic indices, conflict index, and ethnopolitical exclusion. I'm also going to include how many clusters we want to create and let the tool run. Now, one tip is if you're looking to understand how these tools work, always hover over these question marks, or actually click the question mark because it takes you to the documentation of the tool. Not only does it explain how the tool works, but if you're a Python developer, it also provides you some examples on how to call the tool using ArcPy, providing all the parameters and an explanation of all the parameters. So now that we have the outputs of the tool, you have this layer with 4 clusters signifying where attributes were clustered. But the way that you can actually interpret this is by opening up this box plot that gets produced by the chart, or by the tool rather, in conjunction with the tool. So in this example, we have one group that is characterized by low population index. So it's a lot more sparse, but it has a high conflict index and a high ethnopolitical exclusion index. So this region of the data set may be quite a bit more prone to specific types of conflict, and the teams that are there to remediate may want to be different for that region. Another region that stands out to me is this area with low ethnopolitical exclusion. So these are the regions that probably have a bit more control in the political process. Another interesting point here is that even though this clustering is not occurring with contiguity in mind, you see a lot of spatial patterns emerge from the output, right? All we're doing is clustering with respect to the values in those 4 fields. But with that output, you actually see this very clear north-south divide between that cluster that is quite a bit more secluded and has a higher conflict from the rest of the country. If you do want to include contiguity as a factor or as a constraint in your analysis, there is another tool that lets you do that. And that tool is called spatially constrained multivariate clustering. So it's quite similar, but it adds a new constraint that everything has to be contiguous. And the brief example I have of that has to do with ecological marine units throughout the world. Each one of these corresponds to an observation in the ocean, and all of these have metrics related to the health of the ocean, such as dissipated oxygen, nitrate, phosphate, silicate, etc. And what we can do in this case, I'll simply show the history run of that tool. We can pass all of these ecological marine unit features to the tool and provide the analysis fields that we want to cluster by. So these are attributes. But we can also tell the tool to use contiguity as an additional constraint in the output groups. Additionally, we can also change how many permutations will be used to calculate membership of each cluster. And that can be actually very powerful when you're trying to determine how likely is it that a particular feature may be part of one cluster or another. So I'll simply show the outputs for now. And once again, I do recommend that you not only look at the output layer, but you also take a look at the box plot that gets produced by the tool to understand each cluster. So there's a few important clusters that immediately stand out. So this group over here stands out simply because of its low salinity values. And that really stands to highlight essentially the inland oceans of the world with low salinity, which are quite distinct from the rest of the data set. Now, if you are curious about which of these ecological marine units may belong to one or another group, you can take a look at that distribution of membership probability and make selections, for instance, for the ones that really could have gone one way or the other. And that can be important if you are working on an analysis that can be a bit more subjective and you're not sure particularly which parts of the cluster or which features should belong to what cluster or the other. This can help you make some decisions that are a bit more subjective there. And you can notice if I select some of the records that have lower membership probability, they generally pertain to areas that are really at the edge of one cluster and at the start of another cluster, at least by looking at this map. So that's one example, but certainly another important topic these days is the concept of deep learning. Very often people look to automate the generation of data, particularly from satellite imagery or from remotely sensed imagery using deep learning. And that is an important workflow for several of the users that we work with. Some of the key tasks are really pertaining to object detection, to training models that can be given enough information of how different phenomena look in different satellite images, and essentially train a model that can be used to find those objects in new imagery. And there's several workflows where this can be applied, from disaster response to commercial activity. And an exciting development that we have that we can share is the support of this workflow from ArcGIS Pro, whether you're a developer or you're a GIS analyst or a little bit of both. I think what's important is not so much the ability to know the Python syntax and the inner workings of every deep learning module. I think what's important is your ability as a data scientist or as an analyst to really dive into the problem and understand how to generate training data. What type of samples do you need? What type of lighting conditions? What type of representations of the object do you need? Because it's hard enough to produce training data without having to learn all the syntax. So what we've tried to do is make it easier to go through this workflow. And this example that we have here today really is intended to showcase how these tools have progressed. It's an active development, but we can share some of the more recent updates. So what we have here is an imagery layer above Redlands, and it portrays essentially the region right around our campus. And what we're looking to do here is to help tax assessment purposes. We want to find parcels that have pools versus parcels that do not have pools. That type of information can be used to more accurately represent assessment values. So what we can do is we can create a training data set for pools using ArcGIS Pro. I have a bookmark already established here. Now this imagery is not the best quality, but it's enough to let me delineate some pools. And if you select the layer with your raster here and then go to imagery, you can see under classification tools, there's a new capability called label objects for deep learning. And that lets you essentially digitize your training data. Once you've labeled a specific pool, we can go ahead and name that class pool, provide it a value, and continue on. So we can go to one more region, and this starts to facilitate essentially the generation of this training data, particularly for a lot of work. We're looking to generate new training data sets. Maybe there's particular work that doesn't already have training data available. So you may want to use this interface to help your team generate that training data. You can also see that it gives you how many pixels pertain to each class or to each labeled object. And I'm not going to put you through the exercise of watching me generate several hundred training pools. So what I'm going to do is show you an example of several training samples that have already been generated. So that would be step one of this process, right? But all we've done is created a training data set. The next part of this process has to do with exporting this training data into a format that a deep learning model can now interpret. And what I can share with you is this tool called, there we go, export training data for deep learning. A lot of the work that used to take a lot of time in producing deep learning models was in generating these samples, often called chips, that represent different parts of your raster imagery, and they may or may not have your object of interest in each chip. So this tool essentially formats all of this, and I can show you what that may look like when it's done running. You essentially have these different TIFF files that represent different parts of your raster imagery, and accompanying each TIFF file, you have an XML that represents the object of interest if it happens to be within that chip. It has the bounding name or the bounding box with the coordinates and also the other references to the TIFF file. That's called the Pascal VOC or Pascal Visual Object Classes format. That's often used by a lot of deep learning frameworks like TensorFlow or PyTorch. So this tool is used to quickly export that into a format that you can work with there. So the second part of this is quite exciting, which is to actually train the deep learning model from ArcGIS Pro. It can take some time to train, particularly on a laptop, but what we can do is essentially pass the image chips folder as an input training data set and specify an output model, as well as the amount of epochs or how many iterations the model will use these training samples to train with, how many iterations, and then it'll give you an output model file, an EMD file, Esri model definition file that you can use in the next part of the process. By the way, you can also take a look at this tool, and if you're particularly interested in the code behind the trained deep learning model tool, all of these tools are quite accessible. You can see that it uses ArcGIS.learn as part of the process. The final step of this workflow is to detect objects. So once you have your trained model, the final workflow step is to actually run that model on new parts of your imagery. So in our case, we wanted to use a training data set that really just encompassed the southern part of the imagery and see if we can find parcels with pools on the northern part of the imagery. In this case, we would pass the input raster. You would specify the location of your output detected objects as a feature class, and then make a reference to your model definition file, your EMD. Once again, I'm simply going to show you the output of this tool once it's done running. So in orange here, we can see some of the locations where we've detected some pools. And this is a very quick example. It's not perfect by any means, but it's really meant to illustrate how this workflow has, we've done our best to make it quite easier for any user to really engage in deep learning frameworks. Finally, if you do fancy yourself using Python natively, we do have a notebook example and the ability to call all of these tools directly from Python and from a Jupyter notebook, and follow that workflow in a way that may be more familiar to you if you prefer Python. One final shout out that I must provide is to our Spatial Data Science MOOC, which covers this workflow that I just briefly showed. If you actually want to engage in this entire activity, be sure to register for the Spatial Data Science MOOC if you haven't already, or keep an eye out for the next open window for registration. And with that, back to you, Lauren.
Thank you so much, Alberto. I really appreciate it. That was awesome. I think if you ever kind of Google data science, you'll see that one of the ways that people love to explain data science is using Venn diagrams. And I think this is actually a case where I really understand why people want to use Venn diagrams so often for this, and that's because in a lot of ways, data science is this intersection of a lot of different fields, a lot of different domains and knowledge bases. And the main kind of chunks that it falls into are essentially kind of a deep understanding of math and statistics. Then there's hacking, or sometimes it would be called just computer science skills. And then there's what Drew Conway refers to as substantive expertise. I think of this as subject matter expertise, whether it's the field that you're in, or maybe spatial is your subject matter expertise that you're bringing to the table here. And data science kind of sits comfortably in this middle place where all of those meet. And that is great. Most of the time, it's pretty difficult to have all of those skills all at one time to the depth that we'd be comfortable. And I bring this up because this is one of the kind of, I think, most famous Venn diagrams about this by Drew Conway, but he calls out what he calls the danger zone, which is where you have subject matter expertise, let's say, and you've got hacking skills, but you don't have that math and stats background. And he calls that the danger zone because that's where, so you see that machine learning falls between math and stats and hacking. That's kind of bringing together these computer science tricks of the trade for writing algorithms, and then the math and stats knowledge to think through conceptually how those algorithms should work and what their underlying assumptions are and all that. Now, those folks might build the machine learning models, but when we're using those machine learning algorithms without the underlying knowledge of how those algorithms work and how those methods work, that's when we kind of fall into the danger zone. Just because you can run it, like you have the technical skills to run a method, doesn't mean that you understand what's underlying it to the depth that maybe we should in order to feel confident that we are doing our analysis, let's say, responsibly. Now, of course, that doesn't mean that anyone who wants to use these tools needs to go back to school and get a PhD. That's definitely not what I'm saying. I do think, though, that we should be aware when we choose to apply a method that it really is our responsibility to learn as much as we can about that method and to really dig deep and understand what diagnostics are available for us to investigate and validate that method. How much can we do? What do we need to do in order to know that the analysis we've done is good? Not just that it ran, but that it's good and it's valid. And so I think that for every method that you use, there's a lot of research you can do to learn the necessary foundational information about that method to take yourself out of that danger zone. Or I think a lot of the best data science is actually done very collaboratively because nobody can know everything. And so knowing what you know, knowing what you don't know, leaning on others who fill your gaps and vice versa is really powerful. So I think it's just worth noting that yes, we're providing these tools, but we also work really hard to give you great diagnostics and documentation that helps you learn about these methods and points you to places to learn more. So definitely do what you can to dig deeper than just hitting go, because we definitely need to dig deeper if we want to stay out of this danger zone. All right, so the next thing that we want to talk about is integration. This is a really important piece of the puzzle here because we focus on the software development team on building things into the software that we think are going to be as widely applicable and useful as possible. And we specifically try to focus on problems, on methods that are work really well for spatial data, on methods where we think we can add a lot of value either through unique visualization techniques that are more possible within ArcGIS, or by making things easier to use, good defaults, that sort of thing. That's where our focus is. But at the end of the day, there's no way we can put every single possible method into ArcGIS. It just is never going to happen. And so just like I was talking earlier about the idea that we should approach each problem starting with the problem. What's the question that we're asking? Not looking for methods, and then you don't want to be a tool walking around looking for a problem. You want to be a problem looking for the most appropriate tool. And when the most appropriate tool it exists within ArcGIS, that's great. Certainly it makes your life easier, right? But sometimes the most appropriate tool for the problem that you're trying to solve won't be in ArcGIS. And we know that. And so we work really hard to make sure that the way that the ways that you can integrate across to the other ecosystems like R and Python are as seamless as possible. So I'm not going to ramble on too much. I'm going to pass it over to Sean, who's going to talk a bit more about integration and the work that we're doing here. Sean?
Spatial data science often requires building rich custom tools that reach across multiple domains, from domain-specific knowledge in computer science to domain science knowledge in the particular field under study to a deep understanding of appropriate geographic methods for analyzing spatial data. And this need to reach across domains naturally extends well beyond what any one software package can encompass. And while we're continually adding what you can do purely out of the box with our platform, we also recognize the critical role that integrating technology provides. So we really aim to provide a system which allows you to get the best of class experience across multiple platforms. And here are just a handful of the integrations that we work on. We integrate with Anaconda. Anaconda is a great way of integrating your code across many different languages and systems, and it's very widely used in the Python community. It's included in Pro. It enables environment management. It's also the basis for custom Docker containers. So if you're using hosted notebooks, you can build custom images that include any kinds of packages you want. And we also support around 120 packages that we build on our anaconda.org channel. So that's things that people can use independent of our software, custom builds and installs to contribute to that ecosystem. ArcPy and the ArcGIS API for Python both include explicit connections to a number of key Python libraries. So this includes NumPy for low-level transference of multidimensional arrays, pandas. If you use something like SEDF objects in the ArcGIS API for Python, you get direct representation of this data frame representation. There's pandas at the bottom. If you're doing deep learning, then ArcGIS Learn has built-in PyTorch support, and we have tools for working with the PyTorch objects and models. And then notebooks, you've seen notebooks lots of places, but we have rich representations of the data coming out of both of those APIs that are available through the notebook experience. The last one we're actually going to have a demo on, and that's on the R ArcGIS Bridge. So our ArcGIS Bridge can be accessed through a number of different methods, including RStudio, including using it through geoprocessing tools. You can actually host these and put them up into your enterprise environment, and you can use them as web tools. So you can have geoprocessing services running in the background. So you could even have something like a dashboard or a story map that had interactive analysis components being run in real time from R. And finally, we've added some components to make it integrate well with notebooks as well. So I'll be showing you that in just a minute. So to start with the ArcGIS bridge, it has its own product landing page. This is a great place to go if you have any questions about it or you want to learn how to get started. There's reference materials here that show you how to install it, use it with Jupyter, and use it with RStudio. Just in terms of what that looks like, if I'm here in RStudio, I can see that I can have R scripts, and there's a package called ArcGIS binding, and I'm running some code in this environment. I'm not going to dig into this now, but this is a very familiar place for anyone who uses R extensively. One thing is, how do you get this into Pro? Pro actually has a pane for installing the package. We also have built this specialized conda package that you can install by clicking on Python. A little bit of a misnomer here. If you install this package, ArcGIS Essentials, what you'll get is you'll get the bridge package itself, but also a host of other packages that do things like supporting the Jupyter integration, the data type conversions that it supports into rich native R spatial data types. It kind of gives you everything you need to work in this workflow. So once you've done that, installed that package, you can actually make Jupyter notebooks that are built around R. So I have one of these here, and we'll see that we start out by importing this ArcGIS binding package, and then a few additional supporting packages we're going to use later on. So I'm going to go ahead and import these libraries. The first thing we want to do is make the explicit connection back to Pro, and we do this with arc.checkProduct. It'll provide us a little bit of information about the product that we're using, the license level, other details about the package that we've connected to, the version of the ArcGIS binding package. Okay, so once we've done that, the really next starting point is taking data that we have. So this is data that you already know how to work with in Pro using services. It can be service data, it can be feature classes, enterprise databases, almost anything that Pro can open, you can reference using this through R. So I'm going to go ahead and run this code, and we'll see that now arc.open has created a reference to this new arc.fs. So you might ask, well, okay, what are these functions? There's package binding, the package has documentation you can use. You also can just ask for help. So here I could ask for arc.open, and I'll get back the method definition. It'll provide some details about the kinds of things it can take as input, so including things like rasters, how to work with different formats of paths, pretty much everything you need to know. And we could do this for, say, the whole library, get back information about everything that the library supports, all of its methods. We also could do this for things like our next step, which is running arc.select, which is our filtering operation. So one important thing about the R bridge is that it selectively only pulls in the data you ask for into memory. So if we ask about arc.select, we'll see that we can filter on the fields, on a where clause. There's a similar set of tools for filtering rasters. So you can do on-the-fly raster resampling or only get back rasters in blocks, which can be very nice if you're working with, say, global extent data at high resolution. Okay, so with that out of the way, we want to actually run the select now and pull in a couple other layers. And now we can see that we have our data. So at this point, we have our data. It's in this house price object, which we selected. But what do we do if we actually want to work with this more deeply in R? This house price data is an actual data frame. We can query it, we can interact with it, but it isn't a fully native R representation. So what we can do is we can use these conversion methods. This one is data to SF, which will convert this into the native SF package. And once we've done that, we can do things like asking for a plot. And for all these packages that are native R packages, R spatial packages, there's a whole host of additional things you can do with that data. There's hundreds of packages that know how to read and write those native R data types. So in this case, we could ask it to plot. It's going to do this automatic classification to try to give us some interesting plots and try to break down a little bit of the attribute data in there. All right, so that's kind of a basic workflow. You can see that after this, we could take this and pass this to the arc.write commands. We might do some further analysis and then write the results back to a new feature class or enterprise geodatabase or wherever we'd like this data to end up. The other thing we can do, since we're in Jupyter here, is we can use Esri leaflet. So if we import Esri leaflet, we can then tell it that we want a new map. And once we've defined that map, what we want for its base map, the feature layer we want to work with, we can even define a JavaScript function for what we want to be rendered on the pop-up. Now we have an interactive widget. It's not quite as rich as the one that you might be familiar with the ArcGIS API for Python, but it's still pretty handy in contexts where you need a little bit of interactive visualization directly in this notebook context. Okay, and lastly, if you're used to using our large Python ecosystem, you might want to pull in some of that functionality directly while you're running in R. You might be using R to take advantage of some cutting-edge statistical methods that are available, but you also might want to do things that you already know how to do well in Python. Now, of course, you could build separate models and tools and combine all these things together, but it's easy actually to just pull in the things you want directly inside of this notebook environment. So here I ask for this library called Reticulate, and then I can import ArcGIS, the ArcGIS API for Python, and ArcPy, and I can just use these like anything else. So if I import these libraries, once they're finished importing, I can do things like ask the ArcGIS API for Python for a connection. And then I can ask it for things like, oh, I actually want to search the content and get back results that match my particular query. So you can imagine that you have a hybrid workflow here, really kind of harnessing the power of this integration, where you're moving back and forth between these languages to combine it into something that's not possible strictly in either one of those languages alone. And finally, you could call ArcPy, right? So I could be here and I could ask for any ArcPy method. You might get a code signature by copying a run result out of the geoprocessing pane. Any ArcPy code you can run, you can just do that here as well. So that's kind of a really nice way to extend this even further and give you this really rich integration that's combining both of these worlds at the same time.
Thank you, Sean. Okay, so I just want to finish off really briefly by talking about communication. We talked a little bit about this earlier, but I really think it's important to just circle back to it. I love this idea that, algorithms give us answers, but stories are what really drive action. And that is such an important point. It doesn't matter how great our analysis is. It doesn't matter how sophisticated your algorithm is. If nobody can even understand what you've done or why it's useful, then it isn't useful, really. So that's really all about how we communicate and how we tell the stories of our analysis to decision makers, to stakeholders. Another one of my favorite Venn diagrams that I found about data science brings in another piece of the puzzle here. So we've got the programming, which we've already talked about. We've got the stats background, which we've already talked about. This Venn diagram refers to it as business, but we can think about that as subject matter expertise, whatever that subject matter is. But it added another component here, which is communication. And the idea that this perfect data scientist has all of these skills. Well, first of all, we know I don't know many people that hold every one of these skills to the extent to which they'd become the perfect data scientist, which I think is kind of the part of the point of this Venn diagram. But I think the other really important point here is that we really do need to be great storytellers. We need to take the time to bring our analysis that final step. It may seem frivolous if you're somebody who like me, really loves the analysis and isn't necessarily as compelled to spend a lot of time on, creating beautiful maps and a really great description of those analyses. But the more and more I do this work, the more and more I see how critical this piece is if we want the hard work that we've done to be understood and to be used to really drive action. And so I'd kind of compel you to think about this as you're doing your analysis and as you're doing your data science work, and think about how you can work on this communication piece and really be that storyteller. So that's spatial data science within ArcGIS in a nutshell. Lots of different pieces, kind of something for everyone depending on where you're at and what you're trying to accomplish in your workflows. Hopefully this has given you a sense of the different ways you can take advantage of spatial data science all across the platform, and kind of gotten you excited about learning more. Now, there's lots of resources to learn more. There's actually a data science MOOC that was just going on right now. I know that registration closed for that already. Hopefully some of you managed to sign up. But we will run that MOOC again, and I definitely recommend the next time you see it pop up as available to sign up for that. Now, in the meantime, there are a ton of spatial analysis and data science learn lessons. So if you go to learn.arcgis.com, you'll find links to all sorts of workflows. These are essentially tutorials with step-by-step instructions, data that you can download to walk through and do all sorts of spatial data science. And then for a number of the machine learning techniques that we talked about, clustering and prediction, we've got a resources page. If you go to esriurl.com/spatial stats, you'll find links to workshops that go quite in depth into a number of these algorithms. You'll also find there some more detailed information about the ArcGIS bridge and how to download it. So hopefully you'll find those resources useful. We are so grateful to have been able to share this with you today, and hopefully we'll see you next year in Palm Springs. Thank you so much.